In this short video, we're going to learn all about how to solve for the optimal block pricing scheme. Keep in mind that this is a version of second-degree price discrimination. Suppose that Canvas Canopies is a monopoly seller of hand-painted umbrellas. The inverse demand for their umbrellas is given by P equals 200 minus Q. The marginal cost of each umbrella is $50, and the firm has no fixed costs. These are standard assumptions in a block pricing question. We'll have a constant marginal cost and no fixed costs. The question becomes much more difficult without these assumptions. We are told that Canvas Canopies has decided to implement a block pricing scheme. In this block pricing scheme, they're going to sell the first Q1 umbrellas at a price of P1 and an additional Q2 minus Q1 umbrellas at a lower price of P2. Our goal is to determine the optimal block pricing scheme. And keep in mind, this question is set up to have two blocks because there's two different prices and two different quantities for each of those prices. What do we need to know in order to answer this question? It turns out we need an inverse demand curve, the marginal cost, as well as information about the number of blocks. How do we solve this question? We're going to form the profit function with the help of a graph, and this profit function will depend on Q1 and Q2 only. Once we have this profit function, we will maximize profit using standard calculus methods, so we'll be optimizing a function of two variables. Once we know the Q1 and Q2, we'll just go back to the inverse demand curve to determine the prices. So this question is really all about appropriately graphing the inverse demand curve, labeling the two blocks and the associated prices, and writing down the function for profit. If you can get that far, the rest is calculus. Now, I know not everyone loves calculus, but setup here is very important. So let's solve this question. We have information about inverse demand, marginal cost, as well as the number of blocks the firm is going to use too. We are trying to find the optimal profit maximizing block pricing scheme. My advice is always to use a graph to guide the process here, and this is the graph that I'm talking about. So let's just take a look at it together for a minute here. We have a demand curve. It runs from 200 to 200. That comes from the structure of this inverse demand. We've also drawn in our marginal cost curve, which is constant at 50. From there, I've carefully labeled two blocks. I'm not saying anything specific about them. I'm just saying the firm is going to sell Q1 units at a price of P1 and Q2 units, Q2 minus Q1 units at a price of P2. And from there, we can see that the profit is this green shaded region. I'm going to highlight a few areas so we're really clear. This area here, that's the profit from the first block. And as we write that profit down, it would look like this. Profit is equal to Q1 times P1 minus marginal cost, plus we're also going to get a profit from the second block, and that profit is equal to Q2 minus Q1 times P2 minus marginal cost. So these are rectangles, and so we're looking at the base times the height for each rectangle. So I like to start by just sort of mapping it out like that. And then from there, we need to fill in the details. So we know marginal cost is 50. And I've carefully labeled my P1 and P2 here. P1 is 200 minus Q1. Where does that come from? It comes from the inverse demand. Similarly, P2 is 200 minus Q2, which again also comes from the inverse demand. So we're going to fill in what we know here. I'm going to run out of space, but I'm going to try my hardest. Profit is equal to Q1. In place of P1, I have 200 minus Q1 minus 50 plus Q2 minus Q1. Actually, I'm going to bump this down to the next line because I know I don't have enough space. Plus Q2 minus Q1 times 200 minus Q2 minus 50. From here, we can do a little bit of simplification. The simplification I'm doing is I know that 200 minus 50 is 150 for both of these. So I can finally write profit in the following way. Squish it in on the bottom for you here. Profit is equal to Q1 times 150 minus Q1 plus Q2 minus Q1 times 150 minus Q2. So the graph is our guide, and without that graph, we might feel adrift in a sea of letters. So use that graph to guide the process every time you solve one of these block pricing scheme questions. Now that we've written down this profit function with the help of our graph, we need to maximize it. So the first order conditions for a maximum in this case will be that we need the partial derivative with respect to Q1 to equal 0 and the partial derivative with respect to Q2 to equal 0. Now unfortunately here, our function is quite complicated, and so in order to do these partial derivatives, we either need to expand our parentheticals or we need to use the product rule. I am going to use the product rule. So let's start with this partial with respect to Q1. I want you to notice that Q1 appears here, here, and here. So this derivative is going to be quite complicated. The product rule for the first term tells us we're going to differentiate the first function, Q1, and multiply it by the second function. And then we're going to add the opposite, meaning we're going to take the first function and we're going to multiply it by the derivative of the second function. So the derivative of Q1 is 1 times the second function, 150 minus Q1, plus the derivative of the second function, which is negative 1, times the first function, Q1. So that's the product rule for this first term. We don't have to use the product rule on the second term because Q1 only appears in the first function of that compound term. So we just need to take the derivative of this whole thing. Well, in my mind, I'm sort of doing the following. I know the derivative of negative Q1 is negative 1, but that happens to be multiplied by 150 minus Q2. So I'm going to write plus negative 1 times 150 minus Q2. And now all of this equals 0, but I don't have quite enough space, so I'm going to write it like that. I know it's ugly, but that's okay. We also need to take this partial with respect to Q2. This derivative is going to be easier, so you can breathe a sigh of relief. Q2 actually only appears in the second term, here and here. So while we will have to use the product rule, the derivative is going to be a lot more simple. So we take the derivative of the first part. Well, the derivative of Q2 minus Q1 with respect to Q2 is just 1. We multiply it by the second part, 150 minus Q2. And then we add the opposite, where we take the derivative of the second term. Well, the second term's derivative is negative 1. And we multiply it by the first term, Q2 minus Q1, and we set it equal to 0. So we have two first order conditions for a maximum, and what's left is a system of two linear equations and two unknowns. So what we're going to do is we're just going to solve it. And my recommendation is that you start by solving 1 for Q2. So let's do a little expansion. Here I'm going to distribute the negatives in where relevant. So I have 150 minus Q1 minus Q1 minus 150 plus Q2 is equal to 0. And I can start combining terms. I'm going to solve for Q2. I'm sorry, this should say Q1 though, shouldn't it? My apologies, everybody. So just going back, I wrote 150 minus Q1 minus another Q1. For some reason, I wrote Q2, even though I'm pretty sure I said Q1. So this is coming from this term right here, just to be clear. Now we can actually get this question right. So we're going to combine terms. Notice that the 150s cancel, and I can combine these and shuffle them over to the other side of the equality. And I get that Q2 is equal to 2Q1. We can call this equation 3. Just so we're clear, this is equation 1 and this is equation 2. From here, on the next slide, we should easily be able to solve for both Q1 and Q2 with some careful substituting. From our two first order conditions, we have figured out that Q2 is equal to Q1. And now what we're going to do is we're going to simplify first order condition number 2. So just so we're clear, this result here came directly from manipulating this. Now we're going to simplify 2 and we're going to plug 3 into 2, the simplified version of 2. So when I say simplify 2, I mean I just have to deal with this distributing this negative term in. I have that 150 minus Q2 minus another Q2 plus Q1 equals 0. Combining terms, I get 150 minus 2 Q2 plus Q1 equals 0. So we'll call this an updated version of 2. And then we're going to substitute 3 into this updated version of 2 and solve for Q1. We get 150 minus 2, and in place of Q2, I put what I know about it, 2Q1 plus Q1 equals 0. Notice that this substitution has allowed me to generate an equation that depends only on Q1. Simplifying gets me 150 minus 4Q1 plus Q1 equals 0. Combining my Q1 terms and shuffling them over, I get 150 is equal to 3Q1, which tells me that Q1 must be equal to 50. We'll call that equation 4. So we are almost done. All we need to do is substitute 4 into 3 to find Q2. What do I mean by that? We know that Q1, the first block, is 50 units, and we also know that the second block is 2 times Q1, so we just need to plug in, and we can figure out what Q2 is. Q2 is equal to 2 times 50, or 100. So we have done it. We have solved for the profit maximizing Q1 and Q2. Keep in mind that interpretation-wise, this means we're going to sell the first 50 units at some price to be determined in a moment, and then another 100 minus 50, which is 50 units, at a second lower price. So we need to find those prices, and to find those prices, we're going to use inverse demand. What does that mean? Well, the price you're going to charge for the first block needs to be 200 minus Q1, where Q1 is 50. So P1 is equal to 200 minus 50, which is $150. The price you're going to sell for the second block is going to equal 200 minus Q2, where Q2 is 100. So your second block you're going to sell at a price of $100. I want to be really explicit about what the final solution is here. In order to maximize profit, this firm should sell the first 50 umbrellas at a price of $150 and an additional 100 minus 50, which is 50 umbrellas, at a price of $100. So sometimes students make a mistake and they think because Q2 is 100 that that's how many units are sold at this price of 100. That's not true. The number of units sold in the second block is Q2 minus the units sold in the first block, so 100 minus 50 in this case.